For our group project, Garlock Equipment Company teamed up with NDSU for the powered smart cart. The group members included Trevor Maier, Alexander Keller, and James Barthel, with our mentors being Dr. Tangpong and Dr. Selekwa. Our goal for this project was to develop an inexpensive gas-powered cart. To ease the manufacturability, the frame will be kept the same as the current smart cart. The powered smart cart must be able to haul a maximum of 800 pounds under similar conditions that would be seen in the field. To begin this process, concepts were developed and were analyzed under the concept selection process to determine the best solution. Once the concept was selected, a 3D model was then created. And to make sure the new design could handle the maximum load, finite element analysis was performed. When proper analysis was complete, the overall design was then finalized. Engineering prints for all of the new parts that were created were sent off to Garlock Equipment Company to be manufactured. Once all the parts were received, additional steps were needed to complete these parts. This included welding, grinding, drilling, and painting. When all the parts were ready, the assembly process began. The new design called for a keyed axle to accompany the belt and pulley drivetrain. This was attached to the motor by a clutch pulley that allows for a neutral bypass when the cart is idling. This is achieved by a throttle system placed on the handle that adjusts the speed of the cart. A maximum speed of 3.3 miles per hour, which is the average walking speed, is set so the powered smart cart will never outpace the operator. In addition, a dump tray attachment was also implemented to make sure the engine does not flood itself when the tipping process is used. Once the cart was fully assembled, testing on the powered smart cart began. First testing while having no weight, we slowly increased the load of the cart by 50-pound increments. When the maximum load was achieved, the powered smart cart was tested under the same conditions, going up an 8-foot by 1-foot ramp that is commonly used in the roofing industry. The powered smart cart was successful in reaching every target that was set. Although successful, some future recommendations included a transaxle motor along with a chain and sprocket drivetrain. We wanted to give a special thanks to our mentors Dr. Tangpong and Dr. Selekwa, along with the course director Dr. Amiri, for all their guidance and help throughout the project. We also wanted to give a special thanks to Garlock Equipment Company for sponsoring our project, and Director of Engineering Mike Halverson for all his insight. Lastly, a special thanks to NDSU Mechanical Engineering Department, including Rob Saylor and Kim Carlson, for all their help behind the scenes.